Good morning, guys. How are you doing? We've been having some technical difficulties here at the Rathbun house. The internet has been giving me a few issues this morning. What I wanted to actually work with you guys today is what happens when we change the dimensions by using a multiplier for a certain object. What the effect does that have on the area? So, for our first example, we've got this parallelogram, and this side edge is 3, our base is 6, the height is actually 2.8. And so, if I was going to find the area of this parallelogram to begin with, our area is equal to base times height, or 6 times 2.8. And so 6 times 2.8 would be 6 times 8 is 48. Carry the 4. 6 times 2 is 12, plus another 4 is 16. So 16, and we have one spot behind the decimal, so 16.8 centimeters squared. Okay, so what would happen if I took this same parallelogram, but I doubled the length of the base? Now it's going to stay the same height. So I'm going to set up for the same situation, but it's going to be 12 centimeters long. That's going to be a super long parallelogram on my paper. I'm going to have to zoom out for you guys. Let me get it drawn, and then I'll adjust. Okay, so 2.8 centimeters tall. And now it is 12 centimeters long. Okay, so let me adjust. I'm so sorry, I'm having to manually adjust my stand. Okay, so to find the area when we've actually multiplied just the base by 2 would be area equals the base times the height again, so 12 times 2.8. And this time, when I multiply 12 times 2.8, I'm going to end up with twice as much, actually. 2.8 times 12 is actually going to be 33.6 centimeters squared. Okay. Well, rather than multiplying just the base, what if we had just multiplied the height instead? So what if I had a parallelogram? Instead of 2.8, the height for this parallelogram is going to be 5.6. Okay, 5.6. But our base is going to remain 6 centimeters. So the height was multiplied by 2. The base stayed the same as her original. Okay, so area is going to equal base times height, so 6 times 5.6. Okay, and again, we got the 5.6 by multiplying the 2.8 by 2. Okay, so 6 times 5.6 is 36. 6 times 5 is 30. Plus 3, 33.6 centimeters squared. Okay, so notice that if I double the height, then I doubled the area. If I doubled the length of the base, I doubled the area. Okay? What if I double both the base and the height? What would happen then? So let's try that. Okay, so my parallelogram is going to be 5.6 centimeters tall. And it's going to be 12 centimeters long. And we want to look and see what our total area is going to be. So again, 5.6 centimeters tall, 12 centimeters long. Area is equal to the base times the height. So 12 times 5.6. And if I multiply 12 times 5.6, well, let's see. That is actually, if I type that into our calculator, it is going to be 67.2 centimeters squared. Okay? So, what actually happened compared with the 67.2 times or versus the original parallelogram with an area of 16.8? If I multiply both the base and the height by 2, or if I'm doubling both the base and the height to get an overall area, we actually have increased our area by 4 times the amount. So in other words, if I have the same multiplier for both the length of the base and the height, then I am actually taking that multiplier and squaring it before I multiply to get the area of the original. So 16.8, but I doubled the base, I doubled the height, then that gives me 4 times the 16.8 to give me 67.2 centimeters squared. Now, here's the thing. If I tripled the length of the base and I tripled the height, 3 times 3 is 9. And so if I tripled the length of the base and I tripled the height, then I would have 9 times the area. If I multiplied the length of the base and the height both by 4, 4 times 4 is 16, so my area would increase by a factor of 16. All right, so I hope this helps. I'm going to give you some problems to work on. These are due on Friday, so by the end of the day, Friday. Um, I hope you have a great weekend, and I'll be back with you on Monday.